Okay, ladies and gentlemen, we're going to talk to you about lipids today. If you look at the examples on your slide, you have butter and oils, and you have donuts, and then you have meats with a hamburger and french fries. Meat has a smaller amount of oils or lipids in it than some, but then your french fries are cooked in oil, so they can be quite bad for you. But let's go on and talk about our objectives. Hopefully, at the end of the video, you'll be able to tell me the functions of lipids. Give examples of fatty acids, phospholipids, triglycerides, steroids, and waxes. Can you explain what hydrophilic and hydrophobic mean in terms of lipids? Can you differentiate between saturated fats and unsaturated fats? Can you draw and describe what a fatty acid is, phospholipids, triglycerides, steroids, and waxes? And then explain the relationship between fatty acids, phospholipids, triglycerides, steroids, and waxes. Alrighty, let's get started. Function. Lipids are going to give us long-term energy storage. In other words, carbohydrates gave us short-term, but lipids are going to give us long-term, and you're going to store it in very funny locations. Females tend to store this long when you eat excess. It's going to be stored in your hips or your thighs. Men tend to store it in their gut. Storage comes from, if you look at the diagram in here down below, all of these carbon to hydrogen bonds. There's long chains of carbon and hydrogen bonds throughout the lipid molecules. We call those a hydrocarbon, and that's where we get a lot of this energy. The elements that make up lipids are carbon, hydrogen, and oxygen. The same as carbohydrates, except you're going to look at this diagram again down below or the one off to the side. There's not as many O's in these, so the way you're going to tell the difference between a carbohydrate and a lipid is you're going to look at it, are there lots of oxygens or an equal amount of oxygens and carbons, or are there just a few oxygens? And as you can see here, there's lots of carbons and hydrogens, but not many O's. You'll notice the shape are long chains, and we are going to draw them as long straight lines when we draw them out. The monomers of lipids are fatty acids. The first example we're going to talk about is glycerol. You're going to make glycerol in the lab as well as a fatty acid. And they're unique because they happen to have a hydrophilic end and a hydrophobic end. Hydrophilic means it likes water, something that likes water, hence the word hydro is water. Philic means likes, so it's water-loving. Hydrophobic, on the other hand, is water-fearing. So this is a unique molecule that has one end that likes water and one end that doesn't. And that brings us to understanding also what is saturated and unsaturated. If you look at the diagram at the bottom of the page, you have a long chain of hydrocarbons and one that's very straight. In other words, there isn't any more room for anything other than the hydrogens and the carbons, and it's all carbon to single bond carbon all throughout. You look at the unsaturated and you notice you've got a double bond of carbon in there, and that's pretty much how you tell the difference between a saturated and an unsaturated fat. If you look at these two types of fatty acids, saturated fats, as a result of having all single carbon to carbon bonds, that makes the substance solid at room temperature. So that's what your butters are made up of. They're carbon to carbon bonds with single bonds in between them. Whereas your oils have every now and then a carbon double bonded to carbon, and that makes them liquid at room temperature because that gives the molecule that little bit of a bend, gives it a little bit of flexibility, and that causes the substance to be liquid at room temperature, and that would be your oils. So your polymers, there's 4 different types of polymers. You are responsible for knowing each. The first one is going to be a triglyceride, and that's going to be 3 fatty acids joined together with 1 molecule of glycerin. Your phospholipids is 2 fatty acids, and your waxes are a long chain of hydrocarbons. Steroids are going to be quite unique because they're going to encompass having fused carbon rings. So let's look at each of those. Triglycerides, they're 3 fatty acids joined to 1 glycerol. You made these in lab, and again, if you look at the picture here, we have a nice glycerol, and attached to it are 3 fatty acids. You'll notice they're long chains here in these fatty acids of carbon to carbon single bonds, carbon to carbon single bond, carbon to carbon single bond. So we know that would be a saturated triglyceride. Over here, you have carbon to carbon single bonds, carbon to carbon single bonds, but you have one that has a carbon to carbon double bond. So that makes this to a combination of a triglyceride that's an unsaturated fat. Most of the foods you eat today are going to be encompassed by triglycerides. So when you're eating a triglyceride, you're eating a glycerin and 3 fatty acids. We're going to break those down and separate them out and use them as energy. Phospholipids is just 2 fatty acids. So if you look at this diagram here, it has the 2 tails. We're going to represent phospholipids as a balloon with 2 lines coming off of it. And these are 2 wiggly lines, so we know that those are unsaturated. You could make 2 straight lines and it would be a saturated phospholipid. Phospholipids make up cell membranes, and if you look down below, there's a picture of a phospholipid with its 2 layers of fatty acids. It's got 1 balloon with 2 little tails, 1 balloon with 2 little tails, and that's where your phospholipids are. If you look at waxes, we have, and you guys might be familiar with beeswax or candle wax. And what do you know about waxes? They're waterproof, or they hold water in, or they hold water out. And that's pretty much all you have to know about waxes. Some plants have waxes as a protective coating to prevent animals and insects from eating them. But in general, what you need to know about waxes is that they're a waterproof substance. The last one is steroids. And steroids are made from, clicked that too fast, made up of carbon to carbon fused rings. And that's how you're going to identify them different from carbohydrates. Hormones are an example of steroids, and cholesterol is an example of steroids. Hormones, things like testosterone and estrogen. They're going to govern why you have certain reactions in your body, and it also gives you the identification of being male or female. Cholesterol, you've maybe heard your parents talk about cholesterol. Something is high in cholesterol, or I have high cholesterol. It's a molecule that can be sticky to your arteries and veins and cause blockage. Now, steroids often get a bad rep because people misuse them. In other words, they've been misused to increase muscle mass and change your body. But in general, steroids are actually quite good for you and can have a lot of good applications. That's all there is to lipids. Let's talk about your review. Can you give examples of lipids? Can you give me the function of lipids? The elements that are involved in lipids, the shape of lipids, the monomers, 2 monomers of lipids, glycerol and fatty acids. Is something saturated or unsaturated? What does hydrophilic and hydrophobic mean? And then the 4 different polymers that exist. On the next page, you have a chart. Hopefully you can answer that. And then on the following page, you have a list of your vocab. Good luck with the chart and your vocab. Thanks. See you in class.